Bismillahirrahmanirrahim. Today we are going to speak about the integral of vector functions. Before we discuss the limit, continuity, and continuity of the vector function, also we discuss the derivative of the vector function. And we said that the limit or the continuity or the derivative of a vector function is just to find the continuity or derivative for each component of the vector function. Say that, given that, for example, it's given the vector function r of t, which is equal to f of t, d of t, and h of t. The derivative for the vector function is equal to the derivative for each component. Then the same thing, the integral of the vector function, integral of r of t dt is equal to the integral of each component. Just direct forward in the integral of the vector function equal to the integration of each component of the vector function. For example, let's evaluate the given integral. Number one, find the integration of the function from -1 to 2 of the vector function ti plus 3t square j plus 4t to the power 3. dt with a limit from -1 to 2. This is definite integral. So all what we need to integrate each component of the vector function. So this is equal to the integration of the first one t is equal to 1/2 t squared I plus integration of 3t squared equal to t to the power 3 j plus 4t to the power 3. This is k. I forget to write k equal to t to the power 4 k. And the limit between -1 and 2. I have to find now the value for each one for these limits. The final answer will be constant vector. It is not a function vector or vector function. Now evaluate, replace t by 2. The first one will give me 1/2 t to the power, or 2 to the power 2 is equal to 4 minus 1. This is the first component. Replace t by 2 minus 1 to the power 2 is equal to +1. The second one, j, replace t by 2, I will have 8 minus -1. Because -1 to the power 3 is equal to -1. The third component, 2 to the power 4 is equal to 16 minus -1 to the power 4 is equal to 1. Okay. So this will be 3 over 2 I. It will be a constant vector because this is definite integral. We know that the definite integral will give me constant value, plus second one will be 9 j plus 15k. So this is the idea of integrating a vector function. Take another one. Number 2. Let's take the integration of 0 to 4 of square root of 2t plus 1I minus square root of tj plus sine of pi t. This is k dt. As we did before, just find the integration for each part of the vector function. So this is equal to. The first one is 2t plus 1 to the power 1 half. This one to make it step by step. This is 0 to 4 of 2t plus 1 to the power 1 half I minus t to the power 1 half j plus sine pi t k, which is equal to the integration for this power. Just add 1, it will be 3 over 2. Divided by that power, it will be 2 over 3. Multiplied by 2t plus 1 to the power 3 over 2. Dividing by 2. This is by u substitution. I will have 1 over 2 there. This integration by substitution, we can find this half 1 over 2. So this is the first component. Minus 2 over 3 t to the power 3 over 2 j. Sine pi over 2. The integration for sine is minus cosine. And by the substitution, this is pi over by multiplied by t, I will divide by 1 over pi k from 0 to 4. So the integration is, it will be 1 over 3 2t plus 1 to the power 3 over 2i minus 2 over 3t to the power 3 over 2 minus 1 over pi cosine by t. And the limits from 0 to 4. Now evaluate what's given there for the integration or for the limits. The first one will have 1 over 3. Cancel this one, this one. Now replace t by 4 first. I will have 8 plus 1 to the power 3 over 2 minus now replace t by 0. It will be 1 to the power 3 over 2. So this is the first component. This is I. We replace or substitute t by 4 first, then we by 0. Now let's move to the next component. Minus 2 over 3. 4 to the power 3 over 2 minus 0. This is the second component now. J. Third component, I have minus 1 over pi, replaced by pi over 4, or just by, I'm sorry, replace t by 4, we'll have cosine four pi minus cosine of 0. And this is the third one, k. So the first one, I have 1 over 3. This is 9, square root of 9, because this one have mean square root. So square root of 9 is 3 to the power 3 equal to 27. Multiplied by 27 minus 1i, the first one. Minus 2 over 3. This is 8 minus 0. Square root of 4 is equal to 2 to the power 3 is equal to 8. This is j. Minus 1 over pi. Cosine of 4 pi. This is even number. So 4 pi is equal to 1, and cosine of 0 is equal to 1. So this will be 1 minus 1. 1 minus 1. That will be 0. Okay. So the final answer will be now equal to 26 over 3i minus 16 over 3j. And the third comment will be equal to 0. So this is the idea of integrating a vector function. Just find the integral for each part or each component of the vector function. The second point that will be discussed today is the length of space curve. Of space curve. The length of a space curve is given by S is equal to the integration of A to B of the magnitude of the derivative of the vector function, which is equal to the integration of A to B. The magnitude is equal to magnitude of the derivative is equal to the f prime of t square plus t prime of t square plus h prime of t square dt. This will give me the length of the curve in the space. For example, let's find the length of the curve traced by the given vector function. On the indicated interval. with that given r of t is equal to, say, a cosine of t, a sine of t, and c of and c t on the interval 0 less than t less than 2 pi. So we need to find the length of the curve given by this vector function or traced by this vector function. So first of all, we need to find the derivative. Equal to minus a sine of t. A, the derivative of sine is cosine, and the last one is c. So this is the derivative. Now the length will be given by s equal to the integration from 0 to 2 pi of the magnitude. Magnitude will be given by the first one square, that will be a square sine square. Plus, second one is a square cosine square. Third one is c square. So that's the integration of a square sine square plus a square cosine square plus c square. These two can be combined together to give me a square. This is 0 to 2 pi integration of a square plus c square dt. Take a square as a common factor for the first two terms. I will have sine square plus cosine square, which is equal to 1. So the remaining will be a square plus c square. Now in this function, there is no t, which means that the square root of a square plus c square is constant. This is constant. But there is no t in this square root. So we can take it out. This is one of the properties of the integration. We can take the constant outside. Zero to 2 pi of dt, which is equal to the constant a square plus c square multiplied by t between 0 to 2 pi, which is equal to 2 pi multiplied by a square plus c square. So the value of t between 0 to 2 pi will give me only 2 pi. So the length of the curve is equal to 2 pi multiplied by square root of a square plus c square. Let's take another example. Say example number 2. With that, the vector function given by 3t I plus 2 over 3j plus square root of 3t square k over the interval 0 and 1. T is between 0 and 1. So in the first step, we have to find the derivative. That will be derivative of 3t is equal to 3i. for j, okay, it should be, forget to write t to the power 3. J is t to the power 3. And the derivative for the second component will be 2 t square j. Derivative of the third component will be 2 square root of 3t. Okay. This is the derivative of the vector function. Now the length will be given by bs equal the integration from 0 to 1 of the magnitude, integration of the magnitude of the vector function. Sorry, the magnitude of the derivative. The first one will give me 9. Second one will be 4t to the power 4. Third one will be 4 times 3 is equal to 12 t to the power 2 dt. So I need to find the integration for this function. Square root of 9 plus 4t to the power 4 plus 12t to the power 2. And this is equal to 0 to 1. Arrange it as 12t or 4t to the power 4 plus 12t to the power 2 plus 9dt. Which is equal to now this is 4t to the power 4 plus 12t to the power 2 plus 9 can be written as 2t square plus 3 all to the power 2 dt. This is by special factoring. It is 2t to the power 2 plus 3 all to the power 2. This is perfect square. So we can take this out, remove the square root with the square. This is equal to 0 to 1 of 2 t square plus 3 dt, which is equal to now integrate 2t to the power 2 equal to 2 over 3 t to the power 3 plus the integration of 3 is 3t between 0 and 1. Now replace t by 1 and then replace by 0. The value will be 2 over 3 multiplied by 1 plus 3 multiplied by 1 minus 0. That will be 11 over 3. So the length of the vector in this space or between 0 and 1 is equal to 11 over 3 over 1. So 3 multiplied by 3 is equal to 9 plus 2 equal to 11 over 3. So this is the idea of finding the length of a curve in the space. It is just the integration of the derivative or the magnitude of the derivative of the vector function. Integrate, evaluate, or find the value of the definite integral, and that will be the length of the vector.